everyone. So today we have been taking this. I'm reading this machine learning, I think, exercises, and it just explanation in the fundamentals of what is a machine learning and types of machine learning. So I will just discuss what I have read, and also I have made, I think, notes. And this is the, I think, notes for. So this is the notes and let us see what I have done. So it describes a language which is machine learning, a language, a system. So this is part of a process training a piece of software called model to make a useful prediction. So in general, machine learning is most cases used for prediction, and I think this generation, content generation, this has been added after this LLMs that we have seen, ChatGPT and everything. But mostly it used to make a useful prediction. Now there are many types of machine learning, and some of them are supervised, unsupervised, and reinforcement learning. And next one is the large language models or a generative AI. So a basic supervised learning is a where we give a data points. The model is trained on the data and we provide the correct answer for that. So that is why it is called a supervised learning. Supervised in the sense that uh, humans give ML system data with the known correct results. So the model makes a prediction and then it compares its results to the uh, correct results that we provide. In the data set that we provide, there is two categories. First one is the feature and second one is the I think first one is the feature, second one is the okay, I forgot what it is. Feature, I think second one is the okay, okay, let me see in my notes. Second one, what is the second one? What is the second one? Features and label. So this is first one is the feature and second one is the label. Now, what is a feature and what is a label? So the feature is, let's say I have a model which makes a prediction about the rainfall or weather patterns. So in rainfall, I can give multiple features. Could be that what is the temperature for that particular location, what is the location longitude or latitude for that particular location, so, or the what is the historical weather pattern for that location. Now, what is the label? Label is the result, or we can say the output of it, and all the features that we are choosing. These are the inputs that we provide, and the label is the output that we provide. So the label is the for this particular weather model is what is the uh, rainfall, what is the exact amount of rainfall for this particular location. So that is the label. So in the supervised, yes, in the supervised, there are two regression classification. We'll read about it later. But in the supervised, we provide correct answers, and the model has to learn the relationship and to be precise, a mathematical relationship between the features and the label because it already has the we have already provided the correct results. Okay, now moving on. There are two types. The first one is the regression, where you make a predictions and it predicts a numerical value. And second one is the classification. We classify a particular, like whether this email is a spam, whether this content is a spam, or whether this is genuine or fake, that kind of a thing. It is classification or regression. Now, in the unsupervised, we provide a data set that is not with it is not segmented or it is not labeled. So there is no feature, no labeling. So it generally clusters data based on its own understanding. So we categorize it piece of data. So that is the unsupervised part with cluster. Now, third one is a reinforcement learning. Reinforcement is works like a reward or penalty kind of a thing, where for each correct step or each correct answer or each correct predictions, we provide a reward, and for each of the incorrect, we provide a penalty. Now, each of this, like in the supervised, yes, in the supervised, if it makes a correct prediction, now the closer, okay, we will read about it later. But there is something called loss function, which is the difference between the how close the model is to the actual or the correct result. So our goal is to reduce that error, loss function, loss error. And generative is the, of course, these models which provide output like text to text or text to image. These are various kind of, I think, different models, and the input is user text, user prompt, and output is images or video, anything that. Okay, so this is a basic overview that I have been reading. I just wanted to highlight. Now there is a whole. So now we move on to this is supervised learning. Now after supervised, there is a regression, there is a classification. So these are some of the important learning concepts in the learning data, data set characteristics. What is a model? What is a training? What is the evaluating? What is the inference? So model is a piece of software or a piece of code that we have already know. Now training, because before the model is actually deployed for use case, it needs to be trained, that I described earlier, trained on a data set. That is a data set, correct data set. And now that data set in the supervised learning case, we provide a correct features and labels. Now what is the evaluation? We evaluate whether the produced outputs by the model match to the correct result or not. Now what is the inference? Inference is the something after we have done the evaluation. Now we deploy this or use that model for the particular task or a use case. And these are multiple scenarios where the supervised learning can be used, like identifying spam, predicting precipitation. Spam for regression kind of a model, and prediction is for no, identifying spam is for classification, and predicting a precipitation is regression. So yeah, this is the example that I was talking about. So these are all the features: date, latitude, longitude, temperature, humidity, and this is the label rainfall. What is the exact numerical value rainfall we want? Now this is under the regression type of an example. This is a label. This is a labeled example. Example of a labeled data set. Now what is this unlabeled? This is unlabeled. Now we have only provided the features, but we don't know what is the output we want. What is the label? Now data set can be large or diverse, small and diverse. But what attributes of a data set would be ideal forever? For ideal, we want large and high diversity. It should be large enough and highly diverse. Now, why it should be highly diverse is because to uh, accurately uh, map or for a fully functional use case in the real time understanding, it is very necessary that it has to understand the different patterns for the data, identify different use cases or multiple pattern sets with because the model can get multiple patterns or any of those patterns in the real world. So in supervised learning, what is a model? It is a complex collection of numbers that define the mathematical relationship between the input features. So these are the input features and the label. What is the correct relationship? A mathematical relationship. Now mathematical relationship means the prediction power, predictive power for each of the features. In the number of features that we see, some of the features have high prediction power on this level. Some of the features have a low prediction uh, power on this level. So during evaluation and training, we check the person evaluating or the training, they check which of these features has a high predictive power, and they may reduce that or remove that, or they check, they can uh, set its bias or weight according to that. This is a labeled example, this is a model, this is a prediction. Now once this is actual prediction, now we update that model. So it is just a graphical format of explanation. Here train ML model. This is a predictor value, this is actual value. Now it is compared and the loss function is created. Now what is inference? When we are uh, satisfied with the results, we can use the model to make prediction for the actual task. That is called inference. Unlabeled examples, example where we don't know what is the output. We want model to find out what is the. Okay, that is all I think I have written linear. So this is the actual example based of linear regression equation. Y is the output that we want, prediction that we need to make. B is the bias, weight, feature value, the value and calculated from training. And we can add multiple. This is the single feature, feature one. It could be multiple features. Now that will be added here. Plus W1, X2, W2, and number of features. Okay, that's all. In the next video, I will share another attempt or any of the learning that I've been doing. Thank you.